Okay, I'm in the weight room here, so you might hear some noise behind me, which is fine. We are looking at arithmetic sequences. This is an example of an arithmetic sequence. Negative 1 is my first term, 3 is my second term, 7 is my third term, 11 is my fourth term, 15 is my fifth term, 19 is my sixth term, so on and so forth. We can actually figure out the seventh term pretty easily. As you look here, there's a common difference. So I go up by 4 each time. So the seventh term is obviously going to be 23. And that's what an arithmetic sequence is. And it has the form, and I'm not going to take the time to show you why, but where it says a sub n is equal to, on the first term, a sub 1 plus a difference times n minus 1. So for example, let's just say here we wanted to check. You could say that a sub 7, which is the 23rd term, would be equal to a sub 1, which is the first term, negative 1, plus the difference, and the difference each time is 4, times n. What are we looking for? We're looking for a sub 7, so n is 7, so 7 minus 1. And so in this situation, 7 minus 1 is 6, times 4, negative 1 plus 24 is 23. So our seventh term is 23, which is exactly what we thought. Eric, well, big deal, I could just count them out. Well, what if you're looking for your 100th term? Yeah, that would take a long time. All we have to do is just say a sub 100 is equal to our first term, which is negative 1, plus the difference of 4 times 100 minus 1. And so therefore, a sub 100 is equal to negative 1 plus 4 times 99 is 396. And so a sub 100 is going to be 395. So that's just a little bit of an introduction to arithmetic sequences. And you got to be used to using this piece where, again, this is your first term and that's your difference. So I think that the question that was given was that a sub 8 was equal to 3, and a sub 25 is equal to 306, and what is a sub 14? Well, this is a little challenging because we're missing some pieces here, but we'll figure it out. And the first thing we want to find is our difference. And so as I go from 3 all the way up to 306, that's a change of 303. And as I go from term 8 up to term 25, that means that I went up 17 terms. So I guess the big question is what do you go up by each time? If you take 303 and divide it by that 17, I'm sorry, Ellie, it's not 306, it's 309. I just didn't look at the problem again. So if we take 306 and divide it by 17 to 18, that means that that's our difference. So again, we went up 306 units in 17 terms. So that means we went up by 18 every time. So we know, like, for example, a sub 9 would be 21, and then a sub 10 would be 39, so on and so forth. We went up 18 each time. Yeah, so we can see what you generate. So the difference is 18. So what that tells us, if we set up a sub n is equal to a sub 1, okay, plus the difference, which is 18 times n minus 1, we have everything we need except we don't have a sub 1. Well, we can find a sub 1 by simply using this data. So a sub 8 is equal to 3. So 3 is equal to a sub 1 plus 18 times. And what is n in this situation? N, okay, a sub n is 8. 3 is the 8th term. 8 minus 1, which is 7. So we get 3 is equal to a sub 1 plus 126 So negative 123 is equal to a sub 1. So now we have our formula. A sub n is equal to our first term, negative 123, plus the difference, which is 18 times n minus 1. And that will produce for us any term that we want. So I think it asks to find the 14th term. So a sub 14 is equal to, take negative 123 and add that to 18 times. What are we plugging for n? We're looking for the 14th term, so 14 minus 1. 14 minus 1 is 13 times 18 is 234. So it's negative 123 plus 234. When we add that together, we get 111. And that is your 14th term.